In this video we are going to be looking at cameras that follow player-controlled characters. This is the fourth video in the Cinemachine series. In previous videos we have looked at Cinemachine basics and the types of cameras you can use, Cinemachine and timeline for animated sequences, 2D Cinemachine cameras for 2D games. You can find the links to those videos in the video description below. If you want to follow along with this video, download the Starter Assets third-person character pack from the Unity Asset Store. You will see this is using Cinemachine version 2, indicated by the red Cinemachine icon on the main camera. Go to Window, Package Management and open the Package Manager. We need to upgrade to Cinemachine 3. The Starter Assets pack will update to Cinemachine 3 easily, with no issues, but this does not mean that all of the projects will update as easily. Cinemachine 3 is a major version change from Cinemachine 2, and the API and data format have changed significantly. For other projects, first ensure to make a backup of your project. Then you can follow the instructions in the Cinemachine Upgrade Guide. The link can be found in the video description below. Be aware some projects may require a lot of work to update successfully. The Starter Assets, however, will update very easily. From the Unity registry, update to Cinemachine version 3. We can now see the blue Cinemachine 3 icon appear on the main camera. The player follow camera is still using Cinemachine version 2 components, so click on the Upgrade Now button to update this. It will prompt you to upgrade. Click on the Upgrade Entire Project to Cinemachine 3 button. All the data is maintained, but the Cinemachine version 2 components are now replaced with Cinemachine version 3 components. We are going to look at the different types of cameras you could use to follow playable characters. We will cover third-person aim cameras, Freelook cameras, pan and tilt cameras, and overhead cameras. So there's a range of player-controlled character cameras. Choosing the right one depends on the type of game you are making. Third-person follow is recommended for over-the-shoulder cameras, first-person cameras and cameras with aiming reticles, where precise aiming control is needed. It has built-in obstacle avoidance. However, rotation control is not implemented by Cinemachine and is delegated to the character controller. Freelook is very easy to set up and is very configurable, but is not recommended for over-the-shoulder cameras where collision resolution is desired. This is because the camera offset extension doesn't always work well with the Deoccluder. Rotation control is provided by Cinemachine. Position Composer and Pan and Tilt is also simple to set up and can be used for over-the-shoulder because it doesn't require a camera offset extension, but it's less flexible than the Freelook. Rotation control is provided by Cinemachine. All of these camera types can be enhanced with a Cinemachine Freelook modifier component to vary the settings as a function of vertical position. We will look at that in the next video, which is top tips for Cinemachine. Overhead cameras are in a fixed position but lack the freedom of movement of the Freelook and pan tilt cameras. Let's take a look at how each of these camera types work. Go to Game Object, Cinemachine, and add a third-person aim camera. Set the player armature as the tracking target. This is the type of camera you would use for a third-person style game. It uses a third-person follow position control and a third-person aim component to keep the camera at a mostly fixed point relative to the target. The vertical arm length can be adjusted to set the height of the camera. The camera distance can be set to move the camera closer to the player. The camera side slider moves the camera from right shoulder to left shoulder. This type of camera doesn't handle rotation. Instead, you will need to create a character controller script to handle character movement and rotation. The player armature in the standard assets comes with its own third-person controller script. During play mode, the camera stays in the same location over the player's shoulder as he moves around the map. Switch off the third-person aim camera and add a Freelook camera. Set the player armature as the tracking target. This uses an orbital follow for position control and a rotation composer for rotation. This allows the user to control camera rotation around the player character. In the scene view, we can see it is using a 3-ring orbit style. This allows the camera to orbit around the player across the extents of these 3 rings. The ring in center is wider than the top and bottom, so you get a tapering at the top and bottom of the rotation. The orbital follow values can be adjusted for both horizontal and vertical axes independently. If you check the recentering, this will return back to default values after 1 second of inactivity and will take 2 seconds to return to default values. These values can be changed. Recentering can be set for both horizontal and vertical, or just one of them. When recentering is unchecked, it will continue to use your new rotation values, even after mouse inactivity. If you only want to rotate on the vertical axis, make the horizontal range 0 for both min and max, or if you only want horizontal rotation, 0 out the vertical range for both min and max. The top, center and bottom rings can be adjusted in height to restrict the area covered by the rotation. Here I have flattened it out a bit. If I set all the ring radius to 4, the camera will not move closer or further away from the target, but keep a constant distance. The radial axis can be used to adjust the distance the camera is away from the target. The orbit style can be changed to a sphere, which then rotates along a spherical orbit. Set the size of the sphere using the radius. Values can be set to restrict the rotations in the horizontal, vertical and radial axes. The input is handled by a Cinemachine input axis controller component. This is using actions that come with Cinemachine. You can of course change these for your own if you want. Adjust the target offset of the rotation composer to raise the view up, then adjust the target offset Y of the orbit follow to lift the camera up on the Y-axis. Now, during play mode, you have a nice rotation around the player with mouse movement, even as the player is moving. Switch off the Freelook camera and add a basic Cinemachine camera. Set the player armature as the tracking target. For the position control, choose Position Composer. Adjust the camera distance to move closer to the player. Raise the target offset on the Y. For the rotation, add a pan tilt. This requires an input axis controller. Click the button and it is added automatically. This is required so you can control camera rotation with mouse movement or other inputs. This once again uses the action maps that come with Cinemachine. Pan and tilt are similar to the orbit style, but are restricted to a pan axis on horizontal and tilt axis on vertical. It is a simpler system than the orbit style, and it can give a bit of a spongier feel to the rotation. Switch off the Cinemachine camera. I have lined up a shot in the scene view so that it is looking directly down on the player armature. Now when I add a Cinemachine camera, it is created in the same location as the scene view camera. This can be used as a top-down camera. For the position, I will use a position composer and set the player armature as the tracking target. Camera distance can be adjusted to move it closer or further away. With no rotation, this camera will now stay in a top-down view as the player navigates the map. You can create Cinemachine cameras to match any angle you set in the scene view. So this is at a 45-degree angle to the player and using the position composer to follow the player. During play mode, it stays in place, always following the player but never rotating. These are the common types of cameras you would use to follow your player character, and you might just want to use one of these in your scene, or you might want to switch between multiple types of cameras. We can do this in this example by adding a state-driven camera. This will switch between different cameras based on which animation state is currently being played. It comes with a Cinemachine camera attached. I'll delete that and drag the camera follow and Freelook camera onto the state-driven camera. Those two will now be added to the list of available cameras it can switch between. Switch on the Freelook camera. All children of the state-driven camera can be switched on. The component will selectively choose which camera will be the active Cinemachine camera based on the instructions you set. It requires an animated target. The player armature has an animator with a blend of idle, walking and running animations. Drag the player armature into the animated target slot. Now we can add instructions. Select the walk animation, I will use the follow camera when the player is walking. Weight is set to 0, so it will transition immediately to this camera when the player starts walking. I'll set min to 1. This means this camera must be active for a minimum of 1 second before it can transition to another camera. This helps to prevent any glitching. Add another entry and choose idle. I'll set this Freelook camera to be used when the player is idle. During play mode, we have the Freelook camera active. Then it transitions to a follow camera when the player begins walking. And back to Freelook when he stops walking. You can create any type of instructions you like and swap between different cameras easily using the state-driven camera. A common issue when using a third-person camera is the view of the player can be occluded by another object, in this case the roof of this building. On the third-person follow component, check on the Avoid Obstacles checkbox. Check on the Ignore tag and choose Player from the drop-down. This is so the player character, which is tagged as player, is not mistaken for an obstacle. The camera radius can be adjusted, seen here with the red spheres in the scene view. This indicates how far an object is from the Cinemachine camera to be considered an obstacle. Obstacles are any objects that have colliders that are not set to triggers. During play mode, the camera now moves closer to the player when it collides with an obstacle. The player is now always in view. In the scene view, we can see the camera instantly avoid the obstacle. If you want that movement to be a bit slower, you can increase the damping into and from collisions. This may, however, result in a bit of clipping as it moves through the solid objects. Obstacle avoidance isn't just unique to third-person cameras. You can include this with any type of Cinemachine camera. Here I have added a Freelook camera. From the extension drop-down, choose Cinemachine Deoccluder. Similar to the Avoid Obstacles, however, this is triggered when the view of the target is obscured by another object, so that the target is occluded, which is hidden from view. This also allows you to ignore transparent layers, so for example windows could be placed on a transparent layer and selected here, so it wouldn't trigger a need to reposition the camera. Values can be adjusted to set how far the object must be from the camera to be considered an obstacle, and how long the occlusion time takes place before the camera repositions. Leaving these at 0 will use the camera's current position and analyze all objects between the camera and target, and produce an instant camera reposition when the target is occluded. The strategy drop-down uses pull camera forward by default, which brings the camera closer to the target. You can, however, set preserve camera height or preserve camera distance. These may be used when the layout of your level will benefit from a different option. Clearshot cameras use a shot quality evaluation component to decide which camera, when using multiple cameras, presents the best shot from whichever angle your player is in. Add a Clearshot camera. This comes with a Cinemachine camera that has the Deoccluder component attached. I'm going to remove this from the Cinemachine camera and add it to the Clearshot camera. For the Clearshot to work, you need to check on the shot quality evaluation. Cinemachine Deoccluder provides quality evaluation services, but it's also possible to author your own custom scripts that implement quality evaluation and use that instead of Cinemachine Deoccluder. This will judge between all attached cameras which is the best shot to use when the view has been occluded in your current Cinemachine camera. Whichever camera is decided to be best is given a priority boost to ensure that camera then becomes the active camera during the occlusion, but returns to the original Cinemachine camera after the occlusion ends. So I'll set this Cinemachine camera to use an orbital follow. Notice, orbital follow requires an input axis controller behavior. Click the Add Input Controller button and it is added automatically. For the rotation, I will choose Rotation Composer. Create a new basic Cinemachine camera. Drag it onto the Clearshot camera to parent it to it. This is then added to the child cameras list. I'll call this new camera static. I'll position the view inside this building, and with the static Cinemachine camera selected, go to Game Object and align with View. Now this camera is positioned here. I will leave the position drop-down blank, but for the rotation, I will choose Rotation Composer. The target will be the player. This camera will now pan to look at the player but will not move. On the clearshot camera, give both child cameras a priority. The first camera will be the primary camera to be used outside, so it will have a priority of 2. The static camera will only be used in occluded situations, so will have a lower priority of 1. Remember, the deoccluder will boost the static camera's priority only when the view of the target is occluded, so it will have a higher priority when the player is in this room. We see the orbital camera on the outside, and a blend to the static camera in this room. Then a blend back to the orbital camera when exiting the room. Some real-time strategy games use a player control camera to navigate around the map. We will now look at how we can set one of these up. For this, I am using the Fantasy Kingdom in Unity 6. If you want to follow along, you can download this free from the Unity Asset Store. I am in the demo scene. This is using a custom real-time strategy script to control a Cinemachine camera. This has a position composer which is tracking a camera target object. The rotation control is set to none. It also has a Cinemachine Deoccluder. This is to prevent the camera clipping through objects. The decollider forces the camera up above the object when it enters that object's collider. The camera target is an empty game object that is controlled by the RTS script. During play mode, move the camera with WASD keys. Zoom with the mouse scroller wheel. Rotate by holding down the right mouse button. The RTS script is not moving the Cinemachine camera, but just the target. The camera then follows, as we can see in the scene view. Let's create our own simplified version of this type of camera. Switch off the RTS camera controller. This switches off the script and Cinemachine camera. Create an empty game object. I'll call this target object. I'll set its Y position to 0. Create a basic Cinemachine camera. Set the target object as the tracking target. Set the position control to use a position composer. I'll set camera distance to 20 to get a wider view of the scene. For rotation, add a pan tilt. If you choose not to add an input controller, then the pan tilt will be used just to frame your camera angle. But the player will not be able to rotate this camera. I'll set the tilt axis range to 40 on both max and min. Now it's looking down at the terrain. Add an extension of Cinemachine Deoccluder. Check on Decollision. This now ensures the camera will not move through objects, but will be moved up and over objects with colliders. I'll grow the camera radius. 4 ensures it has a large enough radius to avoid most objects. This camera will move only, so I'll call this Movement. Duplicate this camera with Ctrl and D or Edit and Duplicate. This will be a rotating camera. To enable rotation, click the Add Input Controller. Now the player can move the mouse to rotate on the horizontal pan axis when this camera is active. I also want to enable recentering on the pan axis to ensure it always returns to a value of 0. We will switch between these cameras, so enable priority. This will have a priority of 0. The moving camera will have a priority of 1. This will be the active camera when the scene starts. We will access the input system input actions. Double-click to open. We will use the player controls, the move action, the WASD keys to move, and we will use the attack left mouse button to switch cameras. I also want to zoom using the mouse scroll. Click the plus icon to create a new action. Call it scroll. This will be a value type action. The control type will be a vector 2. For the binding, use the path drop-down and select mouse scroll. Check the keyboard and mouse control scheme and click Save Asset. Create a new script. Ensure it is using the input system and Cinemachine namespaces. Create a public input action asset variable to store the actions we have just looked at. We want access to the move action, left mouse press action, and the mouse scroll action. Store the move position and height in vector 2 variables. Set the min height the camera can reach to ensure it doesn't move under the ground. Create a public zoom speed variable. 3 should be fast enough, but can be increased in the inspector. Store the 2 Cinemachine cameras in 2 variables. Enable and disable the player action map when this script is enabled or disabled. In the start method, find the actions and pass them into the correct variables. In the update method, we want to move the target object. Read the value of the position input and store in the position vector 2. For the scroll, check if the target's position Y is greater than the minimum height. If so, store the scroll height in the height vector 2. Else, if the target's height is less than the min height, set the height Y to match the minimum height. Then move the target using Translate. X and Z will move the object left and right, back and forward. The Y multiplied by the zoom speed gives you the movement up and down to zoom in or out. Now to change cameras. Check if the left mouse button was pressed this frame and make the rotate camera priority 2, setting that as the active camera. If left mouse button is released this frame, set the priority back to 0, making the moving camera the active camera again. Drag this script onto the target object. Drag the input system actions asset into the top slot and the 2 Cinemachine cameras into the next 2 slots. During play mode we can zoom using mouse scroll. The camera moves with WASD keys. Hold the left mouse button to rotate and let go to return to the move camera. Notice there is an unusual blend between the 2 cameras. To fix this, set the blend hint for both cameras to cylindrical position. This forces the blend to always follow a cylindrical movement. So this type of camera can be used in a variety of games, including real-time strategies. And that brings us to the end of this video. In the next video we are going to look at top tips when using Cinemachine in your projects. We will also look at the target group camera for tracking multiple characters or objects in the next video. For more information, see the Unity documentation. Thanks for watching.